so our first step in factoring is always to find the GCF. So this one is a little bit simpler. We don't have to use two parentheses whenever there's an x squared and an x. Here I can pull a 4x out as my GCF, and I'm left with x minus 5. And that's all the factoring there is. Okay. Then, when there's a GCF with a variable in it, we have to set the GCF equal to 0. If there's no variable in the GCF, you leave it alone. I divide 4 on both sides, x equals 0. I add 5 on both sides, x equals 5. And those are my two answers. And be aware, when you have an x squared, that means there's going to be two answers. Okay? The second one, I can pull a 2 out. And I'm left with 3x squared plus 13x plus 12. I bring the GCF down. I know that 3x, the only options are 3x and x. And now I need to make a decision on the factors of 12. Okay? So the factors of 12 are 1 and 12, 2 and 6, 4 and 3. I always check the middle ones first. But you're wasting your time putting the 3 here. You can't have a GCF in a parenthesis. So I'll start with the 4 here and the 3 here. 4 times 3 is 12. 3x times x is 3x squared. I don't need to check that. It's the middle term I need to check. 9x and 4x. Is there a way to make 9x and 4x equal 13? Sure, we just add them. 9x and 4x adds up to 13. So therefore, both signs are positive. I set each parenthesis now equal to 0, and I solve them both. I subtract 4, 3x equals a negative 4, divide by 3, x equals negative 4/3. Here I just subtract 3, and x equals a negative 3. All right, the next two, the tip I'm going to give you is this. Whenever you have an x and an x squared and a constant in a problem like you do here, and you can't eliminate the x or the x squared, you always get it equal to 0 and then factor. That's how you solve trinomials. You got to factor them. You cannot factor anything until you've moved everything over. And I can't stress this enough. You want to keep your x squared positive, even if that means you move two things over. You do not want a negative 8 squared. Oops. Okay? Now in this case here, there's no GCF. So I can go right to factoring. My 8, I have 1 and 8 or 4 and 2 as factors. I'm going to start with 4 and 2. For 15, I have 5 and 3, or 1 and 15. I'm going to try 5 and 3. Now, let's say I did it wrong. Shouldn't even put a sign in to begin with. Let's just put 5 and 3 in. That's 12x, that's 10x. Is there any way to make 12x and 10x 26? There's not. So if that happens, before you change the numbers, switch their spots. I'm going to try 3 here and 5 here. 20x, 6x. Is there a way to make 20x and 6x negative 26x? Absolutely. You make them both negative. And what works out nicely about that is negative 3 times negative 5 still gives me my positive 15. So now that the center term has been checked and is correct, we can move forward. We have 4x minus 3 equals 0, and 2x minus 5 equals 0. And from there, we add 3 to both sides. 4x equals 3. We divide 4 on both sides. X equals 3/4. I add 5 to both sides. 2x equals 5. I divide 2 on both sides. x equals 5 halves. And that's your answer. The second problem, I'm going to move the 19x and the 10 over. In this case, I have to subtract them both. So I'm left with 15x squared minus 19x minus 10 equals 0. The 15x, once again, there's no GCF, so I'm going to start with 5x and x. Oh, I'm sorry, not 5x and x, excuse me. 5x and 3x. The middle terms. I'm going to use 5 and 2 for 10. You're wasting your time putting a 5 there. You can't have a GCF in your parenthesis. So I go right away to putting a 2 here and a 5 here. Watch what happens. 25x, 6x. Is there any way to make 25x and 6x equal to negative 19? Sure. You make your 25 negative, you make your 6 positive. And that allows me to get the correct signs. And now I factored it correctly. 5x plus 2 equals 0. 3x minus 5 equals 0. 5x equals a negative 2. X equals negative 2/5. 3x equals 5. And x equals 5/3. My advice is to write everything out. All right, the next one, our GCF is clearly going to be 4. So I'm left with 6x squared minus 7x minus 3, which is going to be a much easier problem to factor. Once again, I start with the middle terms of 2x and 3x. Now, what's nice about 3, there's no options. It's got to be 1 and 3. And it makes no sense to put the 3 with the 3x. So I put the 3 here and the 1 here. 2x times 3x is 6x squared. 3 times 1 is 3. But I really don't even need to check that, because if that didn't work out, I wouldn't have put the numbers there in the first place. 2x, 9x. Is there a way to make 2x and 9x negative 7? Sure. A negative 9x and a plus 2. So this makes a negative 9x. This sign makes a plus 2x. And then from there, 2x minus 3 equals 0. 3x plus 1 equals 0, and we're solving. 2x equals 3. X equals 3 halves. 3x equals a negative 1. X equals negative 1/3. Our second one, I can pull a 2x out of this. And I'm now left with 6x squared plus x minus 1. If you pull the entire term out, you have to leave a 1 behind. And let's be honest, we haven't learned how to factor x cubes yet. So if you see an x cubed, it's an automatic sign. I'm going to have to pull an x out as well. Now we factor. I'm going to use 3x and 2x because I always check my middle terms. The 1 is easy. It's got to be 1 and 1. 3x, 2x. How can I combine these to be a positive 1? I make my 3 positive and my 2 negative. So it's a minus here and a plus here. Equals 0. Now, when you have a variable in the GCF, now you have to set the GCF equal to 0 as well. All right, if you look at the previous problem, you don't have to set 4 equal to 0. 4 equals 0. But if it's 2x, we do need to set that equal to 0. You divide both sides by 2, you get 0. You add 1 and you divide by 3, you get 1/3. You subtract 1 and you divide by 2, you get negative 1/2. And those are your 3 answers. It's pretty straightforward. We subtract 18 on both sides, and I'm left with x squared equals a negative 18. Now, to solve for an x squared, we always take the square root of it. The square root of a square is the number without the square. The square root of negative 18 is plus or minus 3i root 2. You do have to simplify radicals. If there's a negative in the radical, it is automatic there's going to be an I there on the outside. To simplify 18, it's 2 and 9, 3 and 3. There's a pair of 3's and a 2 left over. So if it was a positive 18, it's 3 root 2. Since it's a negative 18, it's simply 3i root 2. That's the only difference. The second one, I'm going to get that x squared alone as well. We're subtracting 80 on both sides. 2x squared equals a negative 80. We divide by 2, and my x squared equals a negative 40. To solve for the x, I've got to take the square root of x squared. Means I'm taking the square root of negative 40. The square root of x squared is x. The square root of negative 40 is plus or minus 2i root 10. I'm starting at 40, and on prime factorizations. 2 and 20, 2 and 10, 2 and 5. Pair of 2's, and a box around the 2 and the 5. Those are numbers that are not paired up. The pair goes on the outside. The numbers that don't pair up, if there's more than one of them, you multiply them and you put it on the inside. It's an I because there's a negative under the radical. So the answer is going to be plus or minus 2i root 10.